During the 20th century, there were many competing theories about the universe. These included the Big Bang Theory and the steady state theory. The Big Bang Theory, which was proposed by George Gamow, states that at some finite beginning to the universe, all matter was located at a single point. The Big Bang is a highly dense and very hot state from which the expanding universe began. From that time onwards, the universe has been expanding until it reached the state in which it is today. The Big Bang Theory suggests that the entire universe formed after a gigantic explosion which had occurred around 13.7 billion years ago. According to it, all the matter that now exists was created within the first few seconds after the explosion. Subatomic particles joined together to create simple elements like hydrogen and helium. With the forces of gravity and ignition, these gases joined together to form stars. These stars later created the heavier elements in the universe. The light that comes from the galaxies that we observe is called redshifted, and that is called the Doppler effect. All of us have observed the Doppler effect. When a fire engine drives down the road, the pitch of the siren increases as it comes closer, and when it passes and starts driving away, the pitch is much lower. When talking about light, the pitch is equivalent to frequency. And so when something is moving closer to Earth, light would be called blue shifted. If the light is moving away, then it's called redshifted. The more redshifted a galaxy is, the faster it is traveling away from Earth. Redshift is used as evidence for both the Big Bang theory and the steady state theory. It is known that light from other galaxies is redshifted. This means that they are moving away from us. The further away a galaxy is from Earth, the more its light is redshifted. This critical piece of evidence supports not only the fact that the universe is expanding, but also that the beginning of the universe could have been from a single explosion. Once the expansion of the universe was proven, scientists used the theory of general relativity to establish three possibilities for the universe, depending on how much matter it contained. One of the possibilities is called the closed universe. It proposes that if the universe exceeds a certain critical density, then it will collapse back onto itself. The Big Bang theory is based on the closed universe possibility. If the universe had less than the critical density, it would keep expanding and thus would be an open universe. Lastly, if it had exactly the critical density, then it would be balanced and in a steady state condition. The general theory of relativity proves that the universe has a beginning. The equation could also predict how fast galaxies were moving apart, and therefore proved that the universe was expanding. Albert Einstein incorporated a cosmological constant into his equations because he believed in the original steady state condition and wanted to keep the universe from expanding. The difference between the original steady state theory and the current one is that the original one states that the universe isn't expanding, as opposed to the current one, which states that it is expanding. As the Big Bang theory wasn't believed by everyone, during the 1940s and 50s, a new competing theory was proposed by Fred Hoyle. It was called the steady state theory. This theory stated that instead of having an origin 13.7 billion years ago like the Big Bang, the universe had been around forever and was in a steady state. The steady state is a theory of an eternal universe and posits that the universe has no beginning and no end. This idea differs from the critical density condition, because Hoyle did not believe that the universe originated from the Big Bang. The critical density condition is the average density of matter required to cause the expansion of the universe. However, it only occurs after an infinite time. The current steady state theory agrees with the fact that the universe is expanding. It states that space is being constantly created between galaxies, rather than galaxies moving away from each other. The space that is being created in between galaxies makes them look like they're moving away. In the steady state theory, matter is believed to be created to keep the average density of the universe constant. This means that new galaxies can be created in between old ones. Both the steady state and the Big Bang theory emerged in the early 20th century and are similar because they both assume that the universe has no edge or center and predict that over a large enough volume, every part within the universe looks the same. There are two main pieces of evidence that support the expanding universe theory and contradict the steady state theory. Firstly, astronomers have measured the abundance of different elements within planets, the sun, and various stars, and they listed the most abundant elements. These abundances match the amounts in which elements were created in the Big Bang theory very closely. The steady-state theory, however, was unable to explain these proportions. The second piece of evidence is cosmic microwave background radiation. This is the biggest piece of evidence supporting the Big Bang and was discovered in 1965. The radiation is like a fossil remnant of the earliest moments of the universe. As the universe formed, radiation was given off. However, with the expansion of the universe, the radiation has stretched out to longer and longer wavelengths. It has been predicted that the radiation from the beginning of the universe would be at a wavelength of about 7 centimeters. The cosmic microwave background radiation was this wavelength. It was found to come from all directions of the sky, with subtle variations in the radiation. These variations are likely to correspond with the first density fluctuations in the early universe, from which not only matter arises but also stars and galaxies. Therefore, the discovery of the cosmic microwave background confirms the prediction of the Big Bang model. Furthermore, the Big Bang theory is most likely correct because in the 1930s, Hubble discovered that the galaxies were receding from us, just like the Big Bang theory suggested, and how to measure their expansion. Another thing that suggests that the Big Bang theory was correct is the fact that scientists have proved that the universe will eventually come to an end. Although this won't happen for a long time, it is predicted that a big crunch will happen about 86 billion years from now. This contradicts the steady-state theory because it proposes the universe has no end. Fred Hoyle thought of the name Big Bang as a derogatory way to describe a rival theory. The name stuck, and the theory was shown to be correct. His theory was therefore disproved. Nowadays, the vast majority of astronomers believe that the Big Bang theory is correct, because it seems to work quite well. However, the Big Bang theory still has several problems and is unable to answer some of the questions that astronomers pose. Unfortunately, there is lack of any competing theories to question and challenge it. That is why it remains the theory that many of us think is right.